Hello everyone and welcome back to the Math Pundit. Today I'll be going over uniform motion, which is part 2 of lesson 3.9. The worksheet for this lesson is linked below in the description, but because it's all of 3.9, uniform motion is just that second portion of the worksheet if you want any extra practice with these types of problems. Okay, let's get started. Question 1. Bill drove at a speed of 65 miles per hour on an expressway for 2 hours. He then drove for 1.5 hours at a speed of 45 miles per hour on a state highway. What was Bill's average speed for the entire trip? Okay, so we know that his R sub 1, his first speed, was the 65 miles per hour, and it was for 2 hours. And we also know that his second speed, or like R2, is 45 miles per hour for 1.5 hours. So what we're going to do is, to find this average, I'm just going to write all this information down first. So our R1, or rate 1, is 65. Time 1 is 2 hours. And because distance equals rate times time, we can say that distance is 65 times 2, which will give us 130 miles. And then, for our second piece of information that we're given, we know that R2, that's about 2, R2 is 45 miles per hour. Time 2 is 1.5 hours. So if distance equals rate times time, we have 45 times 1.5, which will give us 67.5 miles. Now from this, we can find out the average speed. So how? Well, because we have this and this, we can add these two up. So that those two distances, 130 plus 67.5, that's total distance divided by total time. So this 2 hours plus this 1.5 hours. This will give us 197.5 divided by 3.5, and that gives us our final answer of about 56.43 miles per hour. So that was his average speed for the entire trip. All right, question 2. Two cyclists begin traveling in the same direction on the same bike path. One travels at 20 miles per hour and the other travels at 14 miles per hour. After how much time will the cyclists be 15 miles apart? Okay, well, we know that these two bicyclists are going in the same direction. So just as a rule, whenever two objects are traveling in the same direction, you subtract their distances. So what this will look like for us is R1 for bicyclist 1 is 20, and his time is X. We're just focusing on how much time the cyclist will be 15 miles apart. So the times for both cyclists will be the same. So that means that if R2 is 14 miles per hour, T will still be X because it's just after how much time. We're just figuring out one time. So what we do here, we know distance is rate times time, right? So D equals 20x there, and D equals 14x here. And now all we're going to do is subtract. So we have 20x minus 14x is the distance between those two cyclists, right? So the distance the cyclist 1 has traveled and the distance the cyclist 2 has traveled, right? And that should be 15, right? 15 miles apart. So we get 6x equals 15, and x equals 15 over 6, or if you divide both top and bottom by 3, that is 5 over 2. So after 2.5 hours.